So December 1st, happy December, everybody. So a lot of sort of like little tidbits here. I've got a couple of bigger things that I did get done. One was on the drone photogrammetry page. There was a guy that posted about building a thermal 3D model. So this is something that I'm super duper interested in. The Pix4D Vidoc, by the way, came in. So we should have the ability to make some really nice 3D models of buildings now, which we need to try. This would be a good thing for you to do, Peter. Turn you loose with the Vidoc and just like see how it goes.
Yeah.
But basically it was kind of an interesting little conversation. There wasn't a lot going on with it, but sort of criticisms about the camera and how it was made, but not a lot of conclusions about better ways to do it. So it's always good to just sort of keep your finger on the pulse of stuff like this. You don't want to, it's easy to miss stuff, like people can develop techniques and whatever, and so you want to kind of keep an eye on it. I don't really even know what this is. I got a note about it in my inbox. This is about kind of a web-based GIS that you can use collaboratively. I don't super expect this to go anywhere. I spent like 1 second on it, but just sort of sharing it in case it pops up on somebody's radar down the road. The thing that caught my eye about it was the collaborative nature of it. This is something that is sort of missing. The best case scenario for collaboration right now is sort of like you use Zoom and you share your screen and you enable people to interact with it. But other than like, I guess ArcGIS Online has a little bit of limited ability to collaborate, but not a lot. So that was interesting. I've got to give it. I got to have a meeting with a couple of my team members on the Solomon Islands project, and like, this would be a good case where collaboration would be useful. But I'm probably not gonna learn a new system. So I don't know. Maybe that'll go well for them. Maybe it won't. There's a nice new carrier board for the Cube Autopilot. So this cube is sort of the brain of a drone. These cubes are in all kinds of drones. I haven't taken it apart, but I strongly suspect it's what's in the Alta X behind me. It's in a bunch of our lab drones and lab rovers. But it's got a nice, the cube itself is kind of the brain. This is sort of the equivalent of the motherboard if you're into building computers, but it's got some nice features on it and it's very small footprint. So a pretty nice design. In fact, having access to a 5 and 12 volt tap is probably useful in itself. Generative AI is huge. Obviously, we played around with DALL-E, AI, Luma Labs, which is what we're using to build some of the NERF models. Has a 3D generative model that I got to try out called Genie. They implemented it in kind of an interesting way. So if you join their Discord server, you can have it make stuff. So I had it make some trees. So it made some point cloud representations of trees here. Those worked okay. Adobe has a similar thing. This isn't a generative model from like a prompt, but it's taking a 2D image and creating a 3D model out of it. So I didn't get a chance to dig into this. I didn't see a way to try it, although I didn't spend a lot of time. But if somebody wanted to follow this thread, it would be an interesting one to check out. The idea is, you could take a picture of like a New York street from 1930, and without having the hundreds of images that we usually use for creating a photogrammetric model, you could do it from a single image. And it stands to reason, right? Like as a human, you can sort of figure out what's going on spatially in a 2D image without needing to have 100 images. And so that latent spatial structure that's embedded in any single image should be recoverable. And I think that's what this does. You're still not going to be able to like, see what's on the other side of that building. That would be magic. But you could at least spatialize some of it, which leads to some interesting ways to reanalyze a lot of old urban data. I attended a webinar. These webinars that Esri puts on are pretty valuable. You can get on their mailing list, and they'll just start emailing you when this stuff comes out. Esri, this is one on large area reality mapping. They posted it to, I guess not YouTube, but they posted it online. You can watch it if you're interested. It was like 40 minutes long. It was actually plagued with a couple of technical difficulties. You know, half of the people, including me, couldn't see the screen share for at least part of it. But more to the point, the 3D reconstruction that they're using is based on another engine called the N-Frames Sure software, which we have played around with in the lab. In fact, one of the posters that we did in the lab from 4 or 5 years ago looked pretty, not real closely at N-Frame Sure, but a little closely. Basically what it can do is it can make some really nice high resolution 3D models in a way that like Pix4D's 3D model output isn't really all that great. But you can take the stuff that you create in Pix4D, kind of pass it along to N-Frames and get some good results. It can also use LiDAR data as part of its reconstruction. So some interesting opportunities. You know, Liam, this might be an interesting, N-Frame Sure might be an interesting thing to run, you know, like Carl's data through. So he did sort of a standard model, but, you know, theoretically you could run all of that data, that's great data, run it through Sure and get a model that's honestly like 10 times the quality. It's worth Googling just N-Frame Sure if you're interested in this.
Okay.
The difference in quality between sort of a like a Pix4D reconstruction and what they can do. It's a substantial leap. You know, on the other end of that is like NeRFs, and maybe they're using NeRFs for all I know. The build project is coming along in a couple of ways that are probably of interest. The sound team got, I think they have 3 mics up right now. And so Tanner and Brandon shared how to access that data. So they're now logging that data every day. And we set up a system on Rooster back at Virginia Tech to pull that data and to log it. I think they're also doing that to the CID, so we've got a lot of data redundancy, but basically it just kind of runs in the background. They're using a program called SyncThing, which I had never used before, but seems like a handy decentralized way to share files across the internet. A little bit more here on the dashboard and what that looks like. I got a note yesterday or the day before that the big Ouster OSO OS0128 LiDAR scanner is on its way. So I'm excited to show that to you, Peter. The Virginia Tech, Addison and Shashank at least have seen the OSO in action at Virginia Tech, and we've got some old data, some of the old lab meetings, but it's really quite remarkable what the quality of the scanner. So one thing that we can do with that, Peter, would be to take it to the forest preserve and see if we can map it with that LiDAR. Now the LiDAR itself is a little bit more of an instrument and less of sort of a total package, so it would take a little bit more work to do the reconstruction. But my hope is not a lot more work. If we pair that with a nice GPS, my hope is that we'll get some pretty good results straight out of the gate. But we'll have to try it out. We'll try it out, you know, around Old Johnson, the building, before we hoof it up all the way over there. But I have some high hopes for that. And then I think it would be really nice to put that on the Alta X drone and see what it can do. Again, it's not really made for that, but I think we can maybe make it work. They do sell the adapter for that drone to mount stuff on it. Is called a toad in the hole. It's got this little like quick disconnect that works pretty well. They're a little pricey. It's like a couple $100 for one of these things, but that's worth it if we can get a LiDAR on a drone. Speaking of LiDAR on a drone, we did order the DJI Matrice 350 with the L2 LiDAR package. Hopefully this arrives in a couple of weeks. Peter, this would be something that's probably a little bit more turnkey, that we should just be able to like take over there on an afternoon and fly it and get a bunch of data.
Perfect.
Yeah, so hopefully that all goes really well. We'll see. I'm excited to get it. And then, as I was talking about before the meeting, I've got the Bamboo X1 carbon 3D printer up and running. Really excited about this. It's been sitting in a box for probably over a month, and I just needed to find time to put it together. It's my first time to own one from Bamboo Labs. I've been using a different 3D printer for the last, geez, I don't know, 8 years. So I'm very familiar with that 3D printer, and I wasn't sure how this one was going to go. Lots of good recommendations, but I'm glad I took a chance on it. It's got different, you can put 4 different spools up here. You can, it's got a detachable print bed, so this thing is like magnetic and just comes out. So it's really easy to recover your prints and just grab them. This is a 3D print of Africa that I made. Orienting it sort of a little off kilter so it fits, so I can get it as big as possible on the print bed. But I think that turned out really nicely. I'm teaching World Regional today and doing the last lecture on Sub-Saharan Africa, so I thought it'd be fun to try to get that done and put it up. That's a model that I designed probably 8 years ago, and dug it out of mothballs for this. A couple of weird things about this printer. It's connected to Wi-Fi. There's an app that you use on your phone. There's a program on the computer, the slicer. They're not all talking to each other really well, and I think that's a function of like, you know, institutional Wi-Fi's are sort of like locked down. You've got to have a username and password, and they got to authenticate, and like the 3D printer isn't really designed apparently for that regime. I need to dig in and see if there's a way to make that work. In the meantime, we've got a couple of sort of mediocre workarounds, but we do need to solve that. I was really disappointed to find out that even though the printer is advertised at having a 256 by 256 millimeter print bed, that's only sort of true. There's a little piece that sticks out somewhere. Maybe it's this piece, and maybe it's this piece. I don't know. There's a piece that sticks out, and what that means is that the actual print size is kind of a little bit smaller than that, unless you take off this thing that's sitting on the top that sort of manages the spools. You can remove that, and you can remove a piece in here, and then you can get access to the full print bed. But that's pretty annoying. So a little bit of false advertising, I think. I don't know why. It seems like something they could have engineered around, but must not have been because of the. All right, a couple of the big projects that I worked on. One was a Pix4matic project. So we do have now Pix4D-matic licensed on the computer in the lab. So that's cool. I haven't really worked with Pix4D-matic that much. I've been using Pix4D-mapper for about 10 years. I poked around at Matic for a little bit. Matic does a couple of things that are useful. One is it's supposed to play well with LiDAR data, and it's supposed to do really large scale mapping, handling thousands of images very easily. 10,000 images is not a problem for Pix4D-matic. 10,000 images would have been a problem for Pix4D-mapper. And I have tried to run projects that big, and they just don't work that well. 1,000 or 2,000 on Mapper you can do, but bigger than that you can't. So I was excited to give it a try. Oh, I guess I have a slide about that, but yeah, can utilize LiDAR in much larger image sets. And so here I was just running one of the stock image sets that they have. Peter, one of the things that we need to do, and maybe this is true for Liam as well, I want to get you guys trained up on using Pix4D in detail. So I've got a pretty good Pix4D training program set up, kind of step throughs and sample data and what you should start with and where you should go. Lindsay last year helped me iron out the details of that sort of like training module. There's a lot of stuff that we do in the lab that I want to be able to say like, okay, you're going to need a module on LiDAR and a module on drones and a module on Pix4D. And then I can sort of like give you those things to do, and you can work through that most of that stuff I hope to fold into classes here at Binghamton, but there's always somebody that's going to need this module or that module. So I'm trying to break it up, but that's a work in progress. But Peter, I think I've got the drone one set, and I think I've got the Pix4D one set. I don't think I have one for LiDAR yet, but that's something that I'd be interested in developing with you. You can be sort of the first test case through the LiDAR training module.
Yeah. So is that something I can do? That's something I have to do in the lab, right? Because
no, not necessarily. No, you could do it
at home.
At home, yeah. So if you're interested in getting a jump start on it, like the drones one, I guess you're probably going to want to be here because that's going to take some flying. But the photogrammetry one, you could do like over break if you wanted to.
Yeah, that'd be great. Yeah.
Okay. Cool. All right, we'll make that a priority to get that set before we break for the winter. Pix4D Matic is a little bit weird. So that there's a couple of things that you can do in Pix4D Mapper that you can't do in Matic. One of those things is you can't place GCP markers until you've calibrated the project. And sort of makes sense, but it's not actually strictly required. If your images are geolocated, you should be able to do some of that stuff. I don't know, it's kind of weird. And then this one, the input GCP determines the output coordinate system, and Pix4D Mapper, they could be different. So you might have a lot of times your GCPs are going to be in like latitude and longitude, but you want your output coordinate system to be in UTM. So I don't know why those are so tightly coupled in Matic, and maybe, I don't know, it's a little strange. The impetus for this was some testing with Jen Chow, who's an undergraduate here. Jen Chow actually got first place in the undergraduate poster project for his work on this rover, and he and I got together that Friday afternoon to chat about it. This is Jen Chow, and this is the rover. It's a manual control system. So he's just got a little joystick that he's holding there in his left hand, and he just drives it around manually. He had a DJI, what is this called? It's a little stick gimbal for a smartphone, and he had one. Actually, just got one for the lab as well because it works so well. And then he was using an iPhone and Pix4D Catch. So he had run his tests over at at the nature preserve, trying to map one of the trails. So pretty similar actually to what Johanna had been doing. And getting kind of okay results, but not great. And so he wanted to see if I could help him figure out better ways to do it. And so we spent an hour and a half that afternoon just kind of going through his workflow, which included gathering data and adding on the DJI Mobile 6 smartphone gimbal, which is there in the front, and then figuring out that we can put it in landscape mode. I think those were two important breakthroughs. That the steadier the camera is, the better the image quality is, and the better the reconstruction is. So Peter, you had seen this with your thermal data. As the camera kind of shakes, it smears the pixels a little bit, and it makes it hard to do a reconstruction.
Yeah.
So that happens on a smartphone, maybe a little bit less, but still, if you can keep that from happening, you're going to get better results. So one of the things that we played around with what's the difference between doing this in portrait versus landscape mode? And it turns out kind of a lot. So this is a sort of a look at how those raw images differ. So a landscape mode on the left and a portrait mode on the right. And as you're building the reconstruction, the idea here, at least my thinking was, you get a lot more information in landscape mode than you do in this mode, right? Where I don't know, it seems like a narrower view. Advantages and disadvantages to both, but that was the thinking. So these are the two reconstructions from those on basically the same route. This wasn't super tightly controlled, but not too bad. I think these are probably legit. So on the top is the portrait mode, camera kind of going up and down, and then on the bottom is the landscape mode. And the cars definitely resolve a lot better. Yeah. that would affect things like how much spacing you can have between tracks. Lots of implications for this. This is the dense photogrammetric model. This is just the LiDAR data. So a reconstruction off of an iPhone that has LiDAR is going to be using both the camera data and the LiDAR. So this is just the camera data. That's just the LiDAR data. And then that's both of those put together. So the LiDAR adds, so this is the photogrammetric. This actually does most of the work. A lot of the people think like the LiDAR and the iPhone is kind of what is the key, and that it's helpful for sure, but most of what happens on a reconstruction from an iPhone is still photogrammetric. So again, photogrammetric plus LiDAR. So like the fronts of these cars are especially kind of spotty. And so they fill in a little bit, but not completely with the LiDAR. I took the raw imagery that was collected and just ran that through Luma Labs. And that turned out great. So I would say that this is better than that, right? This is Pix4D. Oops, and then that's a NeRF model. And I think the NeRF-based model is better. Anyway, all right, and the last thing that I had was in-painting. So in-painting is the filling of holes in an image. And I would add to that filling them effectively. Basically, the idea here is that if you're working with LiDAR data set and you want to reconstruct the ground, one of the things that you'll do is you'll like algorithmically remove the trees and the buildings, right? You'll just like write a function that like scoops those things off, and then you're left with these holes in the image that you then have to fill. In the data that I'm working with on the Solomon Islands, the vegetation was pretty thick. So we would get ground returns, but we would also get a lot of not ground returns right next to them. And so the idea is we want to try to like fill in those gaps. This is a kind of an interpolation problem, right? We have data, we just need to use it to figure out what's going on in the pixels that we don't have. I've written a couple of I don't know how much my frustration finds its way into my emails to Esri, but like, you know, when I talk to them about why I don't like their LiDAR tools, this is my classic example. Like they've got a tool that does this. It is absolutely horrible. Like I can't even believe they put this thing on the shelf, and like anyway. So there are a lot better ways to do this. The one that I use in the ground filter that I wrote for LiDAR is an in-painting routine written by a former Kodak engineer in 2003, and it's a finite difference element-based approach. It's basically using partial differential equations to fill in those gaps. And the idea here is a lot of the reason that the elevation void tool doesn't work, and this is where you know, particularly Liam and Peter are getting a bit of an education about, you know, deep GIS topics, because I'm sure Shashank and Addison have heard this before. But the idea here is a lot of geographic data, you make an assumption that it's pretty continuous. So if you're trying to model something like temperature and you have gaps, that's a relatively easy problem, right? Like the temperature here is pretty closely related to the temperature there, right? It's a pretty continuous function. Maybe I'd put an asterisk by that, but you know, precipitation is a little bit less continuous, right? You might have like precipitation fronts that go through, and that actually can affect things like temperature as well. So don't, you know, the fact that temperature is relatively continuous doesn't mean that it's really continuous. But things like elevation are super discontinuous, especially in an urban setting where your elevation in a LiDAR data set might have a sheer face, right? Like the elevation here is one thing, and then the top of the building there, it doesn't go like this, it goes like this. So this is where partial differential equations take into account sort of the discontinuities in the data a little bit better. Now they're not perfect. I've found that the Erica's in-painting routine does really well for small holes, but a lot less well for big holes. And to an extent, that's true for the elevation void tool as well, but in-painting is better. And there's a really good paper that came out around 2020 that basically illustrates this, and like literally tested the Erico's in-painting routine against sort of geographic staples like kriging and inverse distance weighting and a number of other things, and found that in-painting is the best. And this was essentially my finding when I wrote Smurf. Now, all of that's the background. Hopefully one of the things that sort of catches your eye is that the in-painting routine that's in 2003 can't possibly be the best way to do this, right? There must be better ways out there. I often poke into this literature every once in a while to see what's new. And with a lot of the cool AI stuff, the generative AI work in particular that's been going on, I thought, well, maybe there's some cool work going on here. So the best example for in-painting that I know of kind of in common usage is Google's Magic Eraser. And maybe you guys can tell me if this exists on other platforms as well, but on the Google Pixel, for instance, you can take a photo like you see here at left. You can basically select the things in the image that you don't want. So in this case, people, and then it fills in those pixels. Now these are big holes, right? Like if you like remove all of those pixels, if you tried to use something like inverse distance weighting, and maybe I'll show this in my class, like if you tried to use something like inverse distance weighting to fill those holes in, it would look like absolute garbage. And that's what's happening when you use it on your geographic data sets. It's just like when you see it in photographic form, you're like, oh yeah, that's really bad, and you miss it when it's not. Even in-painting would do a bad job with that stuff. So the Magic Eraser is really quite amazing, right? The fact that it can, like a human can do this, right? If you go to an artist and you say, paint over those. In fact, all right, well, maybe I'll show this at the end. There's an artist that basically takes paintings and adds like monsters to them. Have you guys seen these? Like thrift shop paintings, and then like adds in like these monsters, like, all right, I'll find some images of that and share. Humans can imagine what might be going on underneath that. Now they don't know, but they can make a good guess, right? So that's the whole point of this is that they can make a good guess. So NVIDIA had an example of this, and I knew that they did, and I wanted to check it out. So if you click on the Let's Get Started, ostensibly you can try this out, but unfortunately it doesn't work anymore. But the idea is the same. Like given an image here, let's take a look at the Einstein image. You can scrub out parts of it and then it fills that in. Because it kind of knows what the other half of the face looks like. It knows what faces kind of generally look like. There's all these like things that it can use to like contextually fill in the gaps. Now the cool find, so I knew about this. I didn't know about this. So that was cool. I think I'd heard about it, but hadn't played with it. But what I did find was this. So this is Llama, large mask in painting. So the idea here is, can you fill in these big holes, right? It's not the little holes, because I can do that with the in-painting that I have. It's the big holes. So this is Llama. This is a bunch of stuff sort of from their GitHub repo. But you can combine it with things like Facebook segment anything. So this is called in-paint anything. So a pretty neat applications of sort of like taking these different image processing approaches and figuring stuff out. So I started playing around with this. So this is an image that I took with my webcam at left. If you'll notice, there's like a little like plate on the wall, and then these bricks are sort of like damaged. And then I have a logo on my jacket, and then the zipper. So those are the things that I masked out. And you just have like a little paintbrush, and you just like scribble over this and scribble over those bricks and scribble over this and scribble over that. And this is the reconstruction. So it's filled in the wall. This looks pretty good. These bricks look a lot more normal, right? Whatever, like this brick in particular has been filled in and replaced with like a nice clean looking brick. It's done a pretty good job with my logo and my zipper. Like, this is passable. If I showed you this image, your brain wouldn't recoil in terror at the reconstruction. So I thought, let's try this. So there's you can try this out for yourself at cleanup.pictures. It's basically like a web portal implementation of Llama. You can do it on images up to 720p. And if you give it anything bigger, it's just going to downsample them. But there is apparently Python code that you can use to actually use this for things, and that's kind of where I would like to go. But all right, so I like to use these Google Earth images. What is this? It's like a plugin that I use for Chrome. Basically shows me like a satellite photo every time I open a browser. So this is relatively complicated terrain. One of the questions that I had was, okay, InPainting is good at stuff like this, and it's good at stuff like that, and it's good at stuff like this, because these are images that, you know, it's used to seeing, right? These are in the archive of the billion images that are online anywhere. Like, is it tapping into that? In fact, I don't think Llama is, but this is one of the things that I wanted to test. So this is a remote sensing photo. What I did was I masked a bunch of it out, right? I just took a scribbler and scribbled over all that. And this is literally deleting all of those pixels, right? So it's just like scrubbing that whole thing out. And what you get is this. So this is the InPainted version. Wait, this is the original version. That's the InPainted version.
Not bad at all. This looks
Yeah.
beautiful.
Again, like if I showed you this and said, this is the remote sensing photo, you'd go, okay. Like nothing is like, there aren't any visible scars here. It looks okay. When you go back and forth, you see it, you know, like stuff is changing. It's kind of lower resolution, but it's not like markedly worse. All of the badness of the InPainting sort of disappears, which is kind of a good thing and a bad thing, right? Like it's not correct. In fact, it can't be correct, right? Like it's having to make assumptions about what's going on here, and it doesn't have all the information to do so. But this is a very plausible guess, and I'm super excited about this. Like for again a large mask like this, this is amazing. So I have high hopes for what's gonna, the next step is to try this with real LiDAR data and see how it goes. The purpose of this is to make SMRF2 a ground filtering algorithm that works even better. Ground filtering algorithms for LiDAR have been stuck at about 92–93% accuracy for 10 years. SMRF was the best one when I wrote it in 2012, and it's basically still the best one. And I know that they can be a lot better than that. I think that stuff like this is what's gonna be the engine that makes that a lot better. So one of the problems with this is the technology that you're seeing here only works on like 3-channel RGB images, right? This is like a perennial problem of like computer vision people are working on stuff and they want to work with sort of a photograph or a regular image, but I want to work with geospatial data. So we've seen a couple of examples of like depth image processing where you take a depth image and you apply a color map to it, and then you should be able to just reverse that. So the idea here is we would take like a DEM, we'd mask it out, we'd convert it to RGB, we'd run the InPainting, and then we'd interpolate it back again. So this would be kind of the next big project to see if this actually works. It should work, but I'm excited to try it. So sorry, that was kind of a long one. Breaks are actually good for me because I get a lot of time often to get to work on stuff, and I did. So happy to share with you guys today. I don't have a lot of express goals here. The one that's kind of eating away at me is we got the LiDAR running at CID weeks ago now, and we still aren't logging it. I don't even know if Shashank and Addison know that yet, but I never have written the thing yet that actually logs that data. So I need to log that data. Oh, Addison's
Was that like the 18th?
of November
Yeah,
or October?
November, I think.
Oh, well, if it's November, that's not so bad, but I think it might even be October.
Oh, okay. I was doing the backup processing for the like net CDFs and stuff, and it was supposed to go up until like the 28th and it stopped at the 18th for some reason. So maybe
We did have something, oh, so you're saying we might be missing a big chunk of data?
let me check the actual data itself. I
Yeah,
also might have just typed in the date wrong. So
I'm only saying that I'm not logging the data off of the new LiDAR sensors. All of the old stuff should, as far as I know, should still be working.
Oh,
All
okay.
11 sensors should be
I
logging.
might have just typed something in wrong then.
The
You might
kiddie
not
pool,
have.
that's what we are talking about, right, Dr. Pringle?
What?
The kiddie pool section, the
The
multipurpose
kiddie
library.
pool, exactly.
Yeah.
Yeah, I'm just not
Very
logging
good.
data from the kiddie pool, but
Yeah.
I just need a few hours to get that settled out.
I'm
Very
checking
good.
out just to make sure. Yeah, it's there.
Okay.
I don't know why I'll just rerun some of them.
Yeah, I mean, I have been checking in on like the Slack channel to notice like at least it says it's logging. But you know how it is, like it's only partial verify. It's like, you know, are you doing your homework? Yeah, I'm doing my homework. Did you brush your teeth? I did. See. All right. Who wants to go next?
I can go next. Can you see my screen?
Yep.
So I've got updates from the last 2 weeks regarding the CDAC conference and some experiments I did with the LiDAR data. So starting with CDAC, the poster presentation session went really well. The idea to take the iPad was really, really nice. I could not have like explained anything to people if I had not done that. And I was the only one who did it. So for once I thought, is this even allowed? But we had a good participation from tech. I think there were around 7 graduate students and at least 2 undergraduates and around 4 to 5 faculty members. I think the poster session was like very productive in terms of people knowing about the project, people having like multiple ideas, and even in the last meeting, I talked with Dr. Peng and Dr. Baird about like how people were interested in the use case of our project, and my post was mostly on the technicalities of it. So next time I'm going to present anything about it, I think that's something I'll be focusing on. I think we had uh, interest from mechanical engineers and human geographers mostly about like what we are doing. So conferences and meeting Neil members, that's always nice. And I got to meet Clay, who joined our team last semester.
Yeah.
And he was like with Riley, who is also one of the GEA PhD students. I think he graduated or like he's still to graduate, but like he's at ODU right now. So Clay was there and we talked about like the lab and the project and how it's been going. He was excited to see the use of space-time cubes. I think that's the time when he kind of got disjointed with the project. And Clay really sent his regards to Dr. Pringle, and he says he misses the lab very much, and he appreciated you like letting him join the lab.
He texted me, we had a little bit of a text exchange. I wanted to take a quick photo of the slide because I'm going to send it to that to sort of book out. He'll be excited to see that he made the lab report. And Riley was there, I see.
Yeah, I think Riley was one of the people who were doing like the organizing stuff with the CDAC. I think he was representing ODU. I'm not exactly sure. Yeah, but like he was one of the people who was like into the organizational stuff at CDAC.
Cool.
Something next. This is one other thing I did this week. I was supposed to do the CITI training. I completed this yesterday. This was fun. I got to learn a lot about like the social aspects of it, the project, and like peer reviewing and stuff. So this was fun. This took some of my time. I think this was supposed to take 2 hours, but I spent more than 2 hours for it. I've done like 4 of these right now, so I should be good for like a lot of human-based research as well now. So before
can you go back 1 quick second?
Yeah.
I think it's kind of interesting, just geographically speaking, that they put a map of the world there for no particular reason.
Yeah. That's what I was thinking. Like, we just have this world map for.
It doesn't- It's interesting. Sorry.
And they even have this. I think this is supposed to be the globe, so maybe inclusivity. I don't know.
Huh.
So before leaving for CTAG, I was running this experiment on like the different time synchronizations we were doing,
Yeah.
and I had noticed some like differences between NTP and PTP, but I've also noticed like differences between PTPs at different times. So that was an experiment I was running. I've got these 4 animations from August till November, and I have generated the frames for the other months as well. So my basic goal was to like get all the months, like a specific day of a month, and see how the PTP and NTP are working. And the other animations I generated, I still have to make animations for the remaining months. Uh, but these came out real nice. I think this was one of my favorites where like
That one
there's a
is
lot of,
super cool.
I don't know where it is, maybe right there.
Yeah, that is amazing. I love it.
So while making these animations, I'm like seeing a lot of the data that I did not expect. So this has been a fun experiment. So I'll probably put more, and I want to see like every month, and like for each month, I want to see whether it was NTP or PTP, and like I think right now I'm more inclined towards PTP, but I also see some deviations between PTP datasets. So I need to like look at more datasets right now.
Okay.
Yep.
Yeah, this
Uh,
would be stuff, I'll mention this. This is probably stuff that would be of interest to the engineers at Blickfeld, right? Because I suspect that they have no idea what is going
yeah,
on. So and this quite clearly shows the issues. So maybe can we put it on your to-do list to remind me to set up a meeting with them to just show them what's going on?
yeah,
Because then, I mean, we have tried, the whole reason we went to NTP was that so we could use Percept to handle the time synchronization. So I think they think that that's working. And I shut down all of the stuff in the Python script that was also trying to do that, right? So it was like handing off control over the time synchronization to Percept. And it did not, I don't think it, my conclusion is that it did not work. We still, no matter what we do, we're still seeing temporal misalignment.
Yeah.
So I wanna just like have a conversation with them now that we've sort of dotted our I's and crossed our T's, and we can demonstrate. You know, it's tough, like as a company, like it's like any tech support, right? Like you have to be able to sort of demonstrate and replicate the problem. And until you can do that, it's difficult for them to kind of engage with it. But I suspect that maybe now they can.
Yeah, I don't think like there's any other way to see this better, because we are like logging this in 2D. It shows us like really well the temporal misalignment.
Yeah. I think they're going to be excited. You know, we need to talk to them a little bit about. They were interested in sort of the products that we're making anyway, so I think that they'll be excited to renew the conversation. So let's try to do that over the next couple of weeks. Just send an email and have a conversation.
Okay. So apart from that, I kind of got lost going to CDAG on that. So I paused that for a second, and the other thing I wanted to focus on was like for my thesis, I had to like annotate a few thousand frames, and I was thinking I do not want to do that over and over again. So I wanted to like get a proper methodology to how I select the data sets. So on our meeting on Wednesday, I was talking with Dr. Pringle and Dr. Baer, and we kind of talked about how selecting randomly would be a good idea. But if I go for random frames, I cannot see the subsequent movements, and that would be very bad. So selecting at least 1 minute worth of data from the same time is very essential for what I'm doing. And I was thinking to add some randomness, if I take the day and divide it into 3 sections, take 1 minute each from each section. So morning, afternoon, and evening, take 1 minute per each session, and then from that I'd get around 5,000 frames. So this is what the basic idea is. I'd select a random minute from a morning, afternoon, and evening of the same month. So I think this is what I'm going to do. But before doing that, I also had to run some experiments regarding like if I wanted to use DSM or intensity, and there was even an idea of using DSM and intensity as like two band combination. So that's something I wanted to work on. I think the other experiment I ran was before this, I was only running two classes. The first one was people moving, and the other one was people sitting. But when I ran the trained model on a whole day, there was a lot of confusion about furniture being detected as people sitting. So I wanted to see if I tell it that furniture is different from people sitting, it would do a better job. So this is what I did. I started my annotation process for like a few frames. I made three classes: people moving, PM, PS, people sitting, and furniture F. So this and I ran the model. Basically, the idea is to change this YML file. I can have as many number of classes I want to. The one thing I really was interested in is like even if I trained for three classes, uh, could I run it? Even if I annotated for three models, could I train it for one or two models? That's what I wanted to see, but let's see what I have. So after training the data and then trying to detect people, the furniture is consistently being detected, but it's confusing most of the things for furniture. And
Wow.
this is and like even though there's like glimpses of people like being detected as uh people moving, there is almost no detection of people moving. The furniture is like constantly there, but the people sitting is never there. And when it detects some movement, it sees people and then it identifies it as furniture. So I don't know if this is a very good idea for
I would say probably not. Oh my gosh, that works way worse than I would have expected.
yeah.
Uh,
And it just I don't know, like I think the deep learning does not care about subsequent frames, it only cares about how something looks in that frame. That's probably the reason that it's detecting everything as furniture. That's what I think. And this is a great, I think even though I like there is no result that's useful from this, but I think this is a good animation to show how it's so difficult to identify
okay.
people and furniture from a single frame.
Yeah. Huh.
The furniture is always detected. That's a nice thing. If I wanted to detect furniture, I could do it.
Good gravy.
But this performed worse than I thought too.
Like
And
so much
it
worse.
it doesn't even like detect some people. It's the detection is going down.
I, I'm just having trouble wrapping my head around this. I don't even have any theories that would explain this.
Yeah.
Do you have any ideas? Like what would?
No, I'm not sure. It is, yeah.
We're all speechless.
Yeah.
Wow.
I was really disappointed with this because annotating people moving is I think at least 10 times easier than annotating people moving, sitting, and then furniture.
I mean, this is almost. I'm gonna need to think about this for a minute. Maybe we can talk about it more in depth at our meeting on Wednesday.
Yeah.
Um, yeah, let's let it roll around. That's a surprise result. I don't know what to make of that yet.
So this is what I had for this, and I still probably want to try the DSM plus intensity band combination. I don't know if like this is the best way to see it, but that's it. And the other
Yeah,
time I
yeah.
spent, yeah,
We just on that front. So you haven't yet done the DSM plus intensity.
no, yeah, I've
And
not
this
been able
was
to do that.
which layer was this on?
This was DSM.
Okay. So you could I mean you could finish the project and see what happens when you do it on intensity,
Hmm.
and then see what happens when you do it on DSM plus intensity. I don't know, given how bad this is, I don't really expect them to get a lot better. I think we're looking at a fundamental problem with the deep learning. But
Uh,
okay, so the things I'd like to see are this same minute or whatever run against on the intensity plus on like the 2-band, and then try running your just people on the density or on the intensity plus DSM, like a 2-band layer.
yeah, that's what I want to do.
Okay, all right, cool.
So I spent a lot of time writing my SOPs this week, and like other essays. I also spent some time with like the thesis, but I think I need to like accelerate my thesis writing speed. I am going to get like some sections for review, probably by next week to Dr. Springer.
Okay.
That's it. And yeah, so my major goal this week was to like see how if I added more classes, how it would affect the deep learning results. Very disappointing results, but it still it still was worth a try, and I'm still going to like run more experiments. And major goals will be like annotating more data and writing. Yeah.
Sounds great. Thanks, Peter. Peter, I know you might have some time constraints here. Are you up against a class?
Yeah, I do have a class at 11:20, if that's okay.
Yeah, no problem. Did you, we could just, if there's no time crunch, we can do whatever you were gonna do today and just do it next week.
Yeah, that'll be fine.
Is
Yeah.
next week, so we still have classes, that's a regular day here at Tech, are you still up to me?
I should be fine, maybe for next Friday. I know that's the finals for Japanese, and I'm a TA, so I don't know how if she wants me to go in for that, but
Yeah,
um,
yeah, and if
we'll
you
have to
can't be here,
see.
that's okay. The usually what we do for the holidays is we'll go up as late as we can. So I guess probably we'll have a meeting next week, but then we'll be off for the break. And then sometimes what people will do, what I will often do, is because if I wait to present everything by the time I get back, like I'll forget it, or the thing will be like 3 hours long. So I'll record like a little snippet and I'll post that as sort of like a offhand thing, and then people can watch those if they want, or a lot of what we do is sharing with everybody else, but a lot of what we do is also documenting what we're doing. So around the holiday times, I emphasize the documenting. But yeah, Peter, we'll just what were you gonna do today? Was it a article presentation or?
I have some like things that I've been working on in my geography class that like kind of works in tandem with this. So I was gonna just present some of the stuff that I've been doing there.
Cool. Yeah, cool. Well, we'll see that next week. And by the way, if ever there's time constraints, just be like, I've got a class. Can I go next? And part of this is my fault because I talked for like 50 minutes today. But always feel free to like buck the line if you've got stuff going.
Sure.
All right. Yep. See you.
All right. Thank you. Bye.
Have a good weekend.
Bye.
Liam, you
All right.
TA for a Japanese class?
Yes, I'm doing the minor in Japanese, and I do TA.
That's dope. Is it like the beginner class, I guess?
Yeah, I kind of do like all of them. I mostly am like as like formally the beginner and intermediate TA, but I also do help out with like the advanced class since I've already taken it.
That's cool.
Yeah.
Cool.
All right. Who's up next?
I can go real quick. So I have to leave, and mine's pretty short, and I do have class in a little bit.
Sounds good.
Okay, here we go. Slideshow. Okay, so I read an article about Peleliu Island and the conflict there during World War II that was between the United States and Japanese navies. And this article was written by Neil Price and Rick Knecht. I think maybe how you pronounce that. So a little bit of background. The first I want to say half of this paper was essentially a historical recap of what happened on this island, which was interesting, but kind of, I don't know. I felt like it was a little not unnecessary, but I would have, because they kind of skipped out on some other stuff that I thought I would have liked to know more about as opposed to this. But so this focuses on in September 1944, the U.S. Marines invaded the Micronesian island of Peleliu, and it's noted as one of the worst battles in the Pacific Theater. And they noted that one of the kind of reasons behind this is tourist impact, poses risk of heritage site management. So they want to make sure they have a documented of what's there so that what they have to preserve and things like that. And also there is a significant amount of unexploded ordnance on that island due to the conflict, and they obviously don't want people visiting or people who live there to accidentally get blown up. And another thing they noted is that this battle, despite being one of the worst in the Pacific Theater, is largely unreported in the media because all the media people who were covering it at the time thought it was going to be really fast and boring, which in fact it wasn't. So they noted that the objective for this was to work with the Peleliu War Historical Society to preserve the battlefield, and they noted that they had 3 imperatives: conservation, tourism, and demining. So they wanted to make an archaeological survey for the battlefields and all the artifacts, and then promote the indigenous oral histories of the people who experienced it. And then probably the most important is remove unexploded ordnance, and then just assist in managing it and try to get it registered as a UNESCO World Heritage Site. So kind of the field work that they did is it was mostly ground truthing. Despite this paper being really interesting, they did not do a lot of like LiDAR or anything like that. Like their use of those sort of technologies was really limited, which I thought was kind of unfortunate. So from December 2010 to January 2011, they worked with a nonprofit organization from England called Clear Ground Demining, which specializes in the removal of unexploded ordnance. And the goal was to kind of document, obviously, the sites and the artifacts and that sort of thing. But they noted they're only able to document a fraction of the sites, and also, not the full extent of all the sites, just due to the nature of the terrain, and obviously the time intensive having to remove all of the unexploded ordnance takes a while. So those sort of processes take a lot longer than they normally would in other places. So they named various name sites as well as kind of various random sites of just open air that was basically just consisting of leftover vehicles and artillery pieces that were abandoned and just left rusting in the grass. So here in this image, you can see exactly the names of all the named locations. And then, so their methods, again, like what they did is they did a visual survey to identify sites. And I thought that maybe something like this could have benefited from a LiDAR to make an ease of exploring or finding a lot of the sites, as I included a picture later of kind of like a concrete gun emplacement. So I think things like that probably would have benefited. I think this particular research would have benefited a lot from using LiDAR or other mapping technologies. And they essentially just mapped the GPS coordinates and put them on a map so they could visualize them. And then did a lot of written descriptions. But they noted that just because there were so many artifacts that they found, that they kind of only generally documented the artifact material. So they did a very extensive description of the actual location and the site, but as far as the actual things that they found there, they did more roughly just because there were so many. And then they removed all unexploded ordnance from the sites. So here's the number of identified features that they found. So caves refers to just kind of caves with signs of human activity in them. So remains. So these would have been caves that people were stationed, that the Japanese were stationed in for, defense or that sort of thing. So they had various bunkers, foundations, a couple standing buildings, and you can see that they also had random vehicles and aircraft that were just out and about, as well as human remain concentrations where they noted significant amounts of bones, probably from maybe some sort of burial or just a place where multiple people were killed at the same time, as well as various artillery and guns. They found significant amount of bombs and TNT dumps, that a lot of these were still live that they had to deal with, as well as napalm canisters and other miscellaneous items. So here's some of the ground features that they noted. So on the left is kind of an artillery emplacement, and this kind of image is why I thought they would have benefited a lot from LiDAR surveys, because it's hard to see exactly unless you're like right on it. So it could be easy to miss if you're not looking straight into it. And then on the right is just the tracks of a tank. So there's all sorts of various things that they found. And then on the left here is just a giant pile of live grenades that they found, that they had to deal with. And they also mentioned in the paper that the Japanese in this time used a lot of chemical weapons that were sealed in glass vials, and they did find a couple of those that were still live, so that they had to deal with. So this was a very dangerous research that they did. And then on the right is just the map of the caves on the island that they noted. So the takeaway, I thought it was a very interesting paper. It was pretty short, and I'd never really heard about this place before, which is why I thought it was really interesting. However, like I mentioned earlier, it was really lacking in the technologies such as LiDAR, which I was primarily interested in, and I thought they would have benefited a lot from. And that's pretty much it.
Sorry there wasn't more LiDAR in there. I haven't looked at like any of these papers, so you're kind of providing a first look. If you find like, oh, this isn't really about what I'm interested in, then that's fine. But I was interested in these results.
I thought I did. That was kind of the same idea. Like, I thought it was a really interesting paper and really cool to read about, but it did just kind of lack that one dimension of it.
It's when I talk to archaeologists about LiDAR, I think that one of the things is this is why we need more people to do LiDAR, because like I don't even think that archaeologists know what they're missing.
Right.
And it's shocking sometimes, like when I talk to people and I'm like, oh, you should just scan this with LiDAR. They're like, why would we do that? I'm like, well, let me show you, because you can do this like 20 times faster and probably more safely.
Yeah, that's what I was thinking. I was saying if they just did a drone flyby of, and the island, it's big, but it's not that big. So they probably could have covered a large chunk of it with several LiDAR surveys.
Yeah.
And they wouldn't have to really deal with watching where they step the entire time.
Right.
Right.
Yeah. Cool. Thanks, Liam.
Mm-hmm.
All right, Addison.
Yeah, I'll go ahead and share what I have for this week. Can you guys see that okay?
Yes.
Okay, perfect. So the first thing that I was working on was improving the angular filter or making an angular filter, I guess, for my like percept data. Where basically like if two people are traveling in like the same-ish direction and they both experience like a simultaneous movement and pause, like let's say two people walk into the building together and they find a table that they want to sit down at. So they're walking next to each other, they're meeting the velocity requirements, they're close enough to each other, they've moved enough to be considered for a collision. So basically they like meet all of these requirements for a collision, even though they like maybe entered the space together, or they've been walking together, they've been traveling in the same direction. And that kind of hints at the fact that like this probably realistically wouldn't be a collision. So what I'm working on right now is kind of building this like angular filter so that if they're traveling in the like a similar enough direction, so right now I just kind of have this set to be like 60 degrees between them, then they can't be considered for a collision. So down here, this would be an example of like if these two people both met at this location, having been walking from a general similar starting point, that they like wouldn't be basically eligible for a collision because the angle of travel between them is not different enough. But then if you had two people that came from, you know, somewhat different origins, then it's a little bit more likely that like if those people did stop and pause, maybe this wasn't like maybe it wasn't quite of like a planned, let's walk in together, find a table, stop and sit down there. So basically just to try to filter out some of those points. And I have this, I spent a while on this week and I got it working for like an instantaneous angle. So like at the exact second of analysis, it works properly. And so all my like other filters applied on a full day gives us 123 collisions. And then adding in the like angular collision filter yields just 90. And some of the collisions are in the exact same spot. Most of them are actually. But then we can see that like there's some that end up not getting detected. For example, this one here. Some of the ones on the stairs don't end up getting, or all the ones on the stairs didn't end up getting detected. And then like you can see there's a couple others that there were actually a couple new collisions that hadn't been detected previously. I think that the new ones that are getting made are from like the same two objects just happening at a different location because they didn't meet like an angular parameter up until a certain point. So like this one, for example, might have been the same two people as this dot here, or this collision here might have been the same two people from this collision. But it might just be that like the conditions for the angular filter weren't met until this location instead of this location, basically. But what I'm really trying to get done is have either a 3-second or a 5-second like moving average of angular travel, and I want to use circular statistics to do this. And the reason for that is because 358 and 2 degrees are only 4 degrees apart from one another. But if we were to take the mean of those two, it would give us 180 when they should be averaging to 0. And so using like a moving average would help avoid like really slight, for example, if someone does stop moving, what could happen is Percept might detect your stop moving as oh, you moved ever so slightly backwards. And what that would do is it would throw off the angle at which you were moving. If two people came in moving this direction, they both stopped. Percept might detect one of these people as moving even the slightest bit in this direction, and all of a sudden that the angular filter is kind of like met. So taking a moving average would hopefully avoid that from happening.
By the way, quick question. What's the source of your angles? Is that coming from Percept, or are you calculating it from the track data?
I'm calculating it from the track data.
If you get a chance, it might be worth comparing what that looks like the track data versus the Percept data. Mm-hmm. I would hope that they would be pretty similar. If they're not, I would wonder why. Percept is a little bit of a black box, so we don't really know. Maybe they're using a moving average filter as part of their trajectory. I suspect not, but I don't know. It's probably worth a look.
Yeah, definitely. So I got it working additionally with like a I guess it doesn't really necessarily use, if you're using median, you can avoid using circular statistics, which is like obviously not the best proxy for doing this.
Actually, would that be true?
Well, kind of, but not really. I guess it wouldn't use the circular statistics, but it would also be wrong. Where like if you had 5, or if you had 3 points, you had a 359, a 1, and then you had like a 17, the 17 would be the median.
Right,
Which
right.
obviously in this case, it's not the real median of the data set. But I wanted to try it as just like a proxy to see like, does this do a close enough, like, and obviously I didn't think it did. So I ended up kind of just like skipping through that. But it did, I was able to calculate the rolling average, which was good. So I've been working on this on Python. Currently, I'm at this roadblock right now where my average angle is like currently being represented as the same for every single row of data. So I think what I forgot to do is group it by the unique ID before writing statistics. And then I need to specify while calculating that mean that I want the mean for like just 5 seconds of data as well, because I think it's trying to like currently run the mean on everything.
Yeah. Ew.
So I need to figure that out and figure out how to make it not do that.
Oh yeah, that's messy. Okay, 2 ideas. One, you know, if you're lucky, maybe the data that you're getting from Percept is already functional. So if you're lucky, maybe it's doing some of this for you. Percept also records path data. So your last, I don't know how long. Do you know, Shashank? It's like your last 5 seconds of movement, or maybe your last 10 seconds of movement, I don't really know, is encoded in each line. So when it detects an object, in addition to its like position and angular velocity and other stuff, like there will be a path attached to it, and that path would be the track from the last X seconds. So you might be able to just sample that directly. But yeah, if you kind of dig in and do like that could get really ugly. I mean, it would probably be fun and ultimately satisfying when you got to the end, but I could also imagine that taking like 3 days to figure out.
Yeah, probably a lot of ChatGPT is going to be there.
So yeah, either way, I think it's a good growth opportunity for you. You'll learn as you work through that problem, but don't be afraid to throw in the towel if it.
Yeah.
I love the angular filter. I think that this is actually going to be quite helpful, and I think that the idea of using a moving average is also really key. Like I think those are important elements. So when I say throw in the towel, I don't mean on the whole wing, but yeah, I guess I don't know what I mean because you.
I do think at the least I can't move backwards on this thing. I think at the least the like instantaneous angle filter is better than nothing.
That's already good. I mean, 30 fewer collisions, as a percentage, that's probably, I don't know, 20% or something like that. That's good. Like that's a great start.
Yeah, I would say, yeah, at a baseline, I think this is a little bit better than nothing. But yeah, I think it could also be improved upon. And then the other thing is I started this yesterday, the city research training. I need to finish it. I'm planning on finishing it right after this meeting. And then the third thing was Dr. Abaid had got in touch with me asking for some of like the Percept data. So she wanted to look at basically like a single day, but like consistently throughout the semester. So she wanted basically every Tuesday from 8:30 to 9:30. in the morning, and then also every Tuesday from 8:30 to 9:30 in the evening. So I basically like got the list of Tuesdays and went through and just kind of like manually compiled them. I know that I can figure out how to write code to do that for me. But I wanted to make sure that I was doing this correctly since I'm sending it to Dr. Abate and not using it for myself. So I basically manually compiled all of them and turned them into CSV for the morning files, which is this one here. I accidentally grabbed the wrong hour for one of those data, so I had to switch it out. And I guess I was supposed to write the size here, but it ended up being like 100 megabytes for all Tuesdays for 1 hour since the beginning of the semester, which was like 15 Tuesdays. There were more Tuesdays than I thought that there were going to be.
That's a neat data set. And I agree with, part of coding is kind of knowing when it's faster to just do it manually.
Yeah.
It's faster to code. So I think you probably made a wise choice there.
Yeah, I do want to build a way that I can do that, but just for like this specific case scenario.
Yeah.
I had enough going on this week already that I was like, I'm just gonna do this manually rather than finding a way to code it.
I love it. I think that shows good wisdom. Sometimes you can over systematize things, and actually programmers have a tendency to want to do this, myself included. My wife gives me a hard time for it all the time. Like I'm always like trying to solve the global solution, and then she's like, can we just solve this one problem that's in front of us?
I found myself doing that also sometimes. But I was having this issue with the evenings data. And I need to actually take a look at the files themselves. But basically I already have like code that if there were any blank files, they would not end up working when you go to parse it because there's like no data to parse and it breaks. But there were a couple where there are files that were large enough to where they should have data, because they didn't break the size requirement that I have set, where it's like supposed to filter out files of a certain size. But yeah, for some reason it was giving this like unexpected character when decoding the like JSON file. But I managed to figure out how to write some code to actually get around this, which was cool because didn't know how to do this before. But I've been working on this like other unrelated like Python thing just to like help learn more Python. And so I used a like try except syntax, so that it would not only like basically tell me which files would work and which files it could work with, but then also tell me like which files are broken. So there were 2 files here. And I haven't actually looked at them yet, but I need to do that and figure out why those 2 files were broken. But then when I did it this way the first time, I kept getting issues with, I think trying to append. I tried to like put all the files in a list and then convert that list into a data frame, and it didn't like that. So what I ended up doing instead was I basically added in like a new thing down here, and basically if this step could get completed, it added in the like file name to a list, so then I could have like a list of all the working file names. So there were those two files that didn't work, which I also added to like this one called broken list. And then I ran it on the working files, and that ended up working. But yeah, I'm not sure what's wrong with those 2 files, so I still need to take a look at that. But I'm glad that I at least got like that part to work, so that I was able to send it to Dr. Abate, because I had sent her the morning files earlier in the week and was like, there's something wrong with the evening files, like I'm not sure what it is, but I'm still working on that. But I finally got that working, so
Nice work. Thanks for doing that.
yeah.
Okay.
And I guess
I think I've run into this issue once.
You got to take off, Liam.
Yeah, I gotta go get ready for class, but
No worries.
thank you guys.
Yeah.
Yeah, have a great weekend.
You too.
I think I've run into this issue once, like where you try to read a file, it starts reading and then like goes to an error after some time. So I think uh like the size filter you applied for like file size was okay for like files where it had all of the logs missing. But like there might be a chance where like only one log is missing, like in those JSONs, and I think that's where the problem is. Does that make sense? Where
Yeah.
it detects no object for like 2 minutes and it just records like nothing for 2 lines, and that's where this issue is coming from, I think.
Okay. Interesting. I guess that makes sense. So yeah, maybe I need to maybe find a way to get around that better, because I know what I'm gonna end up, what I'm gonna need to end up doing is run this whole run my collision algorithm on like all of the percept data. So I need to find a way to kind of get around doing that. And this works, but it might be very time consuming to process all those JSONs this way, because it takes a bunch of extra steps basically.
Yeah, I don't remember if I actually was able to fix it, but what I did last time I ran into this issue was instead of like using bt.read bitfile log, I would just take the function and try some edits with the function that Dr. Pringle wrote.
I'll have to take a look at it and see what comes up.
I had an idea. I thought about your heading data. You might look and see if moving pandas can help out with this. If the data set were read in, would there be a way for it to make a calculation like that? It would be the kind of thing that I would expect to see in there, because the advantage there is that it's taking all of those points and it's putting them together into a trajectory, but then it's also retaining the attributes as you go. So you might be able to do that.
It probably could. I should take a look at that. I'm sure that there's something in there.
I was poking around on the Esri site, by the way, and I swear I saw something that was talking about trajectories there. Yeah, there is a trajectory type. There's a trajectory dataset tool set. Add data to a trajectory dataset. I don't know what that is. It looks like it's kind of like satellite data though.
That's the Esri one, the trajectory data set?
Yeah. It's just because of the commonality with the moving pandas name, I thought, oh, maybe they're using moving pandas for something. But it doesn't look like it. Yeah.
Doesn't hurt to take a look at least. But yeah, so that's what I have for this week. I guess my goals for next week are to finish the training. I'm hoping to do that today. And then keep working on the like circular angular filter. Because I think at that point, once I get that to the point that I'm happy with it, I think that'll be kind of like the real like endpoint of the working on the algorithm, and then I can start moving on to like the analysis and stuff.
Cool. Sounds awesome.
Yeah.
Good. All right, well, good work, guys. We'll I guess break for the day and see you back next week.
Next slide. Yeah.
So both of you are good for meeting on Friday of next week?
Yes.
I believe so. I think so.
All right, we'll plan on doing that then, and we can see, what are your plans for break? Are you traveling? Are you around?
I'll be around for most of the time. I know I have a couple weeks where I'll be visiting like family and friends and stuff. And then I have a week in January where I'll be out of the town. But other than that, I don't think I'm like super busy or anything.
Okay. How about you, Shishar?
I think I'm going to be around. I don't have any plans for this December.
Okay. All right. Well, if if we are around and we want to get together on Fridays, then I'm happy to do that. I don't like to require that because it is nice to take some downtime. But if people are feeling like we would enjoy it, then we can do that. All right. See you, everybody.
Dr. Miller, will you be able to review the documents?
I will. Yeah. Thanks for the reminder. I'll do that right now.
Yeah, thank you so much.
Bye.
Bye.